The second problem, we need to collect the definitions of properties of the stochastic processes. The first one is Y-sense stationary process. So the WSS process is a stochastic process, which is mean is a constant, and autocorrelation is a function of time difference. And the second one is the independent increasement process, which means that the x of t1 minus x of t2 and x of t3 minus x of t4 on non-overlapping intervals are independent. And the third one is Markov process. Markov process is a process xt that the past has no influence on the future when the present is unknown. And the third one, the fourth one is the normal process. The normal process is a process. X of t is said to be the normal if the random variables of t1, x of t2 to x of tn are jointly normal for any n, and also and any t1, t2 to tn. And that is that the fx of x1, x2 to xn and t1, t2 to tn equals to 1 over the n root of 2 pi times the square root of dxd and times the power the e powers power of minus 1 over 2 times x minus eta of a power of t times say minus 1 times the x minus eta. And the fifth one is the strict since stationary process. So a process is said to be a strict since stationary process if its statistics is not affected by a shift on the time axis. And the sixth one is white noise. So for when process w of t, if we wish to discuss its derivative v of t equals to the derivative of w of t over dt, we have the expectation of v of t is equals to the derivative of expectation to wt is equals to 0, and rv of t1 and t2 is equals to alpha times the impulse function of t1 minus t2. The winner process wt does not have derivative, so we'll use wt equals to derivative of wt just as a notation. When we need to do further discussions instead of dt v of t times dt, we use the derivative of wt. Wt is continuous with probability 1. It has differential dwt, which is a Gaussian white noise with zero mean and impulse autocorrelation function. So a stochastic process v of t is said to be a white noise if the expectation of v of t is equals to 0, and rv of t1 and t2 equals to q of t1 times the impulse function of t1 minus t2. And stochastic the seventh one is that a stochastic process x of t is said to be the mean ergodic process if the limitation of 1/2 times t and times the integral of xt dt from t to minus t equals to e of x of t in mean square sense. And the eighth one is the martingale martingales. Stochastic process x of t is said to be a martingale if expectation of x of t given that x of s equals to x1 equals to x1, where s is smaller or equals to t.